Well, welcome back, everyone. Today I'm honored to be joined by the one, the only Mr. Joshua Edgren. Thank you for joining me.
Happy to be here.
Yeah. Quick introduction on you. So you studied physics at Union University.
It's true.
And then you are a graduate of the Greyfriars, is it Academy?
Greyfriars Hall.
Greyfriars Hall here in Moscow.
Yep.
Catechist and pastoral assistant at Christ Church.
True again.
Reader of mathematics at New St. Andrews, something you're studying. And then
teaching.
Oh, you're teaching.
Yes.
Okay.
Yeah.
Fantastic.
Teaching math. Yep.
Yeah. And then husband and father.
This is correct. Yep.
Lots of fun things.
Indeed.
Yeah.
Indeed.
So we'll jump right in with, I think, the topic that is probably on most people's minds, or at least one of them, which is the recent election we had. A lot of the world is breathing a collective sigh of relief, thanking God for relieving us from what could have been.
Correct.
We have been unburdened by what has been.
Yes.
But the fight's not over.
Correct.
What are next steps?
Yeah. Good question. Part of it depends on who you are and where you are, right? So those of us who are regular Joes with families living in rural Idaho, what that looks like for us is different than what it looks like for potential staffers in DC, right?
Right.
So as I consider that question, thinking about what is the next step for me, what is the next step for guys like me, it seems like we can transition from a mode of, oh no, what's going to happen next? Like, when are they going to come for me? Right. Sort of mindset into, okay, I have breathing space. It seems like I will probably be able to afford groceries. It seems like I will continue to be able to worship my God in the manner that we have been, and so it seems like that's the area of emphasis for guys like me, namely, love your wife, love your kids, worship your God, be in the work of building robust Christian community as we have been, continuing to do so, all the more because we have a reprieve from what's oppressive tyranny that could have come down upon us. So honestly, I think the fight for guys like me looks like worshiping on Sunday morning, teaching my children to do the same, singing the songs of the faith around the dinner table, building.
Is there anything that we can do to make sure that that kind of oppressive tyranny doesn't get its foot in the door again?
Yeah. I think that the main thing to keep in mind is that this is a reprieve, but it's not salvation, right? This is not the end of the story. It's not like, all right, we've won. Any society that is not founded on the Word of God will become a hellhole eventually, right? So our job now is not to cede the neutral space, right. To the conservatives, right? So, all right, well, they'll handle things from here on out, right? Our job is to press on and say, okay, no, Christ is Lord of all, right? Christ is Lord of the public square. This is not the time to relax our wholehearted conviction that it is Christ or chaos. Now's the time for us to continue being committed to the Word of God in its entirety, doing so in private, but then also doing so corporately on Sunday mornings, and then doing so in the public square as our vocation allows.
Right. And as for the people who are in D.C., who do have an opportunity to make some change at least over the course of the next 4 years, how do they make sure that they keep focused? Because I know in D.C. it is a bit of a swamp, and it's easy to become lost in the weeds.
I'm delighted to say that I have no idea the answer to that question.
Okay.
I have no idea what faithfulness for them looks like.
Right.
I hope that someone else does.
Yes. There is also a tendency, as you kind of mentioned, to idolize Trump.
Yeah.
Especially, to be honest, on both parties.
Sure. Yeah.
In different ways.
Yes.
But there is that tendency.
He is the dark god.
Yes.
Yeah.
Hitler on one hand,
right.
and then
or
salvation on the other.
That's right.
What is the danger in that, and how do you avoid it while still seeing that, like, this is a man whom God has put in this place at this time, and is doing good work?
I think that's the key, is recognizing that Trump is gift, not giver, right? That he is gift of God, and that's I think that's straightforward. He is mercy, but he's not the merciful one. He's not the one who gives the gifts.
Right.
And so we receive from God this gift, this reprieve, recognizing that the gift he has given is not the final and ultimate end, right? But just like to idolize anything is to take a created thing and attribute to it divine characteristics. And so to take Trump for what he is, which is a sinful man who yet is being used by God, much like the Nebuchadnezzar or Cyrus or the emperors of old. You would not look at Cyrus and think, yes, you are God, you are the giver of all things. No, you are a gift, and we thank you. We thank God for you. And now we're going to be up and doing. But I think that recognize he's gift, yes, and so we're grateful, but he's not giver. He's not God.
Yeah, and there are people whose it may not be you specifically, but relatives, friends, extended family.
Yeah.
How do you tactfully deal with people who do have, Trump 2024 plastered on the side of their wall?
I think that you don't have to rain on the parade. You don't have to say, like, no, this is actually a bad thing that he was elected. You don't have to say, no, he's look at what a moral train wreck his life has been, and therefore stop being happy. That's not it. But putting in perspective, and I think that you can make that comparison as the conversation allows between Nebuchadnezzar and Cyrus, and also pray for his salvation and pray for God to do great things by him, and that would be wonderful. But recognizing, no, this is gift of God, but it is not a final solution.
Yeah. There's also been an interesting shift in the Republican Party. The Overton window has kind of shifted. It used to be the Republican Party was a little more aligned with Christian values.
Yep.
And over the course of the past 4 years, it feels like it's shifted a little more towards what would be considered 20 years ago as traditional liberal.
Yes.
Right? There's going to be, like, eventually that does lead somewhere.
Mm-hmm.
And generally, as Newton said, once an object is in motion, it tends to not stop.
Correct.
So where does that end up?
Yeah, right. Pastor Doug is fond of saying, or I'm fond of quoting him at least, of saying that the liberals want to drive over the cliff at 80 miles an hour, and the conservatives want to drive over the cliff at 55 miles an hour, right? It's all headed for disaster. I prefer the conservatives because I'm locked in the trunk, right?
Right.
and would like time to get my handcuffs off, right? So I think that's accurate, and it goes back to I was looking at Psalm 12 earlier this week, which contrasts the words of the wicked and the words of God, right? And talking about or referencing those who seek to manipulate by their words. The wicked boast in their ability to control the world by their lies, right? By their speech, and it's contrasted with the word of God is purified 7 times. The word of God is preserved, right? And so that contrast, if you are not founded upon the word of God, eventually you turn into degeneracy. And so that's in my understanding the reason for why this Overton window is shifting, right? This momentum of cultural Christianity has had a lot of, to use another physics term, a lot of mass, right? So it's been hard to move. But it is drifting because it is not fundamentally grounded on the Word of God. It's just grounded in cultural momentum. And as that cultural Christianity goes the way of all things, it is unable to keep this conservatism. What are we conserving anymore? Right. If we are not conserving our commitment to the Word of God, then what are we left with?
Right. So how do we avoid ending up going down, how do we stop the car so we don't drive off the cliff at 45 miles an hour?
Yes. Or any speed, really.
Yes.
I think that begins in the pulpit. It begins with bold preachers who are committed to preaching the Word of God in its entirety. And then it is carried on with men of tender heart who receive the Word and are moved by it, and who raise their children in godliness. It's the long game. I don't know of any quick fix.
Yeah. As is general.
Yeah.
It's very often that there is not a quick fix.
Correct.
But interestingly, the fact that it did the Overton window did shift and it became a little more classical liberal led to Trump getting elected.
Yeah. This reaction.
Right. And people like Elon Musk and RFK Jr. and Tulsi Gabbard, they all came out in support of Donald Trump, which would not have happened,
Correct.
I think, if he was a staunch conservative Christian.
Exactly.
Necessarily.
Yep.
So there is good from that, which begs the question of, we do live in a sinful world.
Yep.
What we're aiming for ultimately is that the politics is completely saved, and both parties, or however many parties there are Christian to their core, right? But we live in a world where compromises need to be made. What compromises should we be aiming for in the next 4 years?
Can you be a little more specific?
Yes. So, for instance, we would love to have abortion abolished.
Right.
That's the kind of thing that we could potentially accomplish in the next 4 years. The issue with gay rights and gay marriage and such like that, I don't know that that's going to be fixed in the next 4 years.
Right.
What's a realistic goal for, look, we know the Republican Party is not Christian. We know they're not as conservative as we'd like them to be. Where should we be aiming while still, balancing?
Right. It seems to me, and again, this is not exactly my area of expertise, but it seems to me that we should aim for whatever we can get. And then having gotten whatever we can get, we should come back and try for more. So compromise, not in the sense of well, tell you what, we can agree that you can murder the baby at this point, right? And we guess that's fine. But, will you at least give us, okay, after 16 weeks, you can't. But will we say it's fine before that? No. None of that. But we're striving to get whatever we can. And so compromise in the sense of being realistic and being strategic and tactical, and not wishing for the sun, moon, and stars right away. And again, it seems to be coming back to that. Is there any quick fix, right? And it seems like in some areas we have the potential for things moving faster. If a total abortion ban was somehow made it through and was on Trump's desk, that would be a very interesting situation, right? But in most cases, that's not what we're looking at. And so, the smash mouth incrementalism that is much vaunted, sign me up.
Yes, and the part of the reason Trump won also is because he labeled himself as the Unity Party.
That's right. Which is deeply ironic and quite amusing.
Yes, but seeing the reactions of many of the liberals who thankfully filmed themselves and put it on the internet. Much
a gift to everyone, yes.
Yes. Yeah, not sure why they did that, but they did, so we appreciate it.
Yeah, Christmas is coming, I guess.
Yes, ironically, some of the many liberal women are saying they're not going to sleep with any men they're not married to for the next 4 years, which would fix a lot of problems.
It really would, yes.
This is...
Your terms are acceptable.
Trump is healing the world.
That's right.
There's obviously... We can laugh and mock these people, but I think it is a good goal to try and reunite America. I think we are more divided, as my dad is fond of saying. If there were state lines like there were back in 1860, it is likely we would already be at civil war.
Sure.
But because we're a little more, it's county by county. That's not really possible. How do we mend the tear that has destroyed America?
You referenced earlier the Elon Musk types or the RFK Jr. types who feel like, well, they were staunchly liberal and then the liberals all went crazy and departed from them and they were left standing right where they were, but not wishing to be crazy. And it seems like what we saw in the election writ large was the normals speaking out and saying, we don't want to be in that world, right? That world is crazy.
Right.
We want to live in this, ultimately we want to live in God's world, right? Whether they said that or not,
Right.
or knew that in their hearts or not, that's what was expressed. We want to live in the world God made, where the sun comes up and the sun goes down, and boys are boys and girls are girls, et cetera, et cetera. So it seems that the answer for bringing any sort of unity or any sort of healing of these tears would just come from living normal life and having fun and being joyful and demonstrating. And it seems like we're seeing a lot of that also on social media in this last week. Where are women's rights being stomped upon, right? Where are women not getting health care for miscarriages? Where is this happening?
Right.
Nowhere.
Yeah.
Right. We just want to not murder the babies, and we want to keep things in line with how God made it. And if you do that, actually, that's where joy and peace and happiness are. And so it seems like that's the answer. Let the crazies devolve into craziness, and let them rant and rave, and then pray for their salvation. And in the meantime, offer a compelling alternative.
Ship them off to Canada.
Yeah, Canada's always a compelling alternative.
Yes.
Yeah.
But that, as far as like Christians dealing with non-Christians, as far like conservatives and liberals, I think crossing the state lines. I know Michael Knowles had some sort of program where he went around and talked to transgender and queer and gay and abortion advocates and such. And kind of tried to like humanize them.
Yeah.
Because I think to a large extent the Republican Party does dehumanize them.
Yeah, sure.
And they have dehumanized themselves.
Right.
But as far as Christian and non-Christian, how do you mend the divide between normal people, but still recognize that like, hey, they're not saved and we are.
Right. This is the glory of the gospel, that Christ saves sinners, right? And Paul writes to the Ephesians, such were many of you, right?
Right.
Such were many of you, and so recognizing that there is this tendency to think of those who have mutilated themselves as being less than human, and recognizing that, well, deeply broken, yes. As was I, deeply broken, as were you, as is anyone apart from Christ. And so the answer is not shipping them off or putting them away or continuing to treat them as less than human, but the answer is forgiveness of sins, as is the answer for me. The answer is the compassion that Christ models for us. So that's true for those who are brothers and sisters. We offer them compassion as Christ does, and we bear with the weaker brother while not compromising the truth. But also for those who are not in Christ, we offer them forgiveness. We offer them the same thing Christ offers. Come and welcome to Jesus Christ. That's the answer.
Yeah, and Jonathan Edwards had that great saying there, but for the grace of God,
go I. Exactly.
And that. But as far as practical steps of how do we accomplish that, live, laugh, enjoy the world that God has given.
Right.
Even if you don't necessarily go to church on Sunday, for all of those people, for all the non-Christians,
sure,
they're still living in God's world.
Yeah,
and
right.
we want to live and laugh with them.
Sure, right. And bring them in. Bring them in.
That's the ultimate goal.
Yes.
But it often starts with Moscow has a block party at the end of Grace Agenda.
That's right.
Which is oddly one of the most outreaching things that we do.
It is.
Is here's some food.
Come and eat.
Yes.
Come and sing. Come and listen to music.
Absolutely. Yeah. But as far as practical steps for like individuals, how do you bring back what would be maybe considered the 2000s America?
Yeah. I think that the results of this election do allow for that. This goes back to kind of what we were talking about before. They allow for us to breathe a sigh of relief and recognize, like, okay, the choppers probably aren't coming, right, at this time.
Unlikely we will go to Ukraine.
Unlikely we'll be drafted to Ukraine.
Yes.
And thus, I have, in a sense, the freedom to be kind to my neighbor, right? The freedom to extend hospitality, the freedom to to be to be hospitable. Actually, I live north end of town, and it's funny. I was surrounded by Harris Walls flags on almost every side, and with neighbors that I actually have good relationships with.
Yeah.
Like they're friendly folk, and we've had them over. They've had us over. We helped them move, et cetera, et cetera. And it's been interesting how the results of this election actually has increased my feelings of warmth and compassion towards them. And we've had very pleasant interactions since the election, which I didn't necessarily expect to be the case.
Right.
But like, okay, no, this is God's world. And because this is God's world, I can show you compassion. I can show you kindness, and all will be well.
Yes, and I'm sure the internet also plays a decent part in, or at least the Main Street News plays a part in making us feel like we're as divided as we think we are.
Right. Yeah.
So we can't escape the internet. But is the idea that we spend more time go touch grass,
our actual neighbors?
As they
yes,
say.
I think so. Yeah.
Yeah.
Mm-hmm. Escape the internet as much as you can.
Right.
Yeah.
Yes. And then there's also, like you mentioned, that these people are not freaking out.
Yeah.
But there are some women who are freaking out,
yeah.
and specifically women, I'm pretty sure. At least they seem to be the ones that are filming themselves.
Yes.
It may be some men as well, but I haven't seen that.
Less inclined to film themselves, at least, perhaps.
Yes. And they're saying things such as, we won't have rights.
Yeah.
Obviously, we want women to have rights.
Right.
But in a perfect world, what are the rights and responsibilities of each gender? And are there any things where, like, each one gender has the responsibility or right to do it and the other doesn't?
Sure. Yeah. That's an enormous question. But broad lines, yes, God has made the world in such a way that he has made, I'm a catechist. So from the Westminster Catechism, how did God create man? Well, God created man male and female. That's the first thing that the Catechism says. He created man in his image, male and female, and with glorious and wonderful differences. And it seems that you can look at how God has laid out the relations between the genders and from his word, and you can understand, okay, yes, the men are to do this and the women are to do that in general, by and large. So I think you're getting at should we have voting by household, right?
That's one of the things.
One of the things that's
heads of household.
Yeah, and that seems only reasonable, right?
Right.
And that as you have the man forming the world and the woman, the wife, filling the world, right? He looks outwards at the wolves and the barbarians and the general marketplace, and he goes out and he fights and strives and then brings back what he hunted and killed, metaphorically or literally. And she takes the slab of meat that he produces that that he brings her, and she makes it delicious and whatnot. So she looks inwards, he looks outwards. He defines boundaries. She makes it a pleasant place to be, and that seems to map on nicely with he being the one to engage in the civil realm, and she being the one to deal with the ramifications of that in the domestic. So it seems only fitting and only in keeping with the word of God for the husband to be the one casting the vote, representing the family in the civil realm. If a woman was the head of her household, either as a widow, we see that in the example of Lydia, or if she is an unmarried but established, effectively having her own household, and if she were to engage in that in the absence of having a husband, that doesn't seem unlawful, but that's a stab for you.
Yeah. Are there any other things that you would change in as far as differences of gender are concerned with the civil realm? Yeah.
I don't know.
Yeah. As far as the Westminster Catechism, I've always had this question. Why is that the approved, gone for catechism? I'm sure there are many others.
Good. There are, yes. There are many catechisms. The ones that are held in highest regard in the Reformed tradition are the Westminster and the Heidelberg, and those are and then there's the Westminster Shorter and the Westminster Longer, which are different. One of them is longer. Yeah, I know.
Which one?
The longer one, yeah.
Okay.
The reason why those are the gold standard is because they are particularly the Westminster. It's tied to the Westminster Confession, which is the sort of the what's the word? The
Standard?
standard, but also the summary or the pinnacle
Yeah.
of Reformed theology, right?
Right. Okay.
So you have the Reformation in the 16th century, and then it's all chaos and it's all swirling, but things are more and more systematized, more and more established, and then the Westminster Confession of Faith is sort of the result or the conclusion of all of that theological swirling, right? So the Westminster Confession is the gold standard, and our church takes some exceptions to it in particular places, but that still is the standard as far as we understand the best summary of the Christian faith, the best summary of what the Scriptures teach, and then the Catechism is the shorter version of that, right? So it's the summary of the summary.
Right.
So why the Westminster shorter? Because it's short, it's concise, it's faithful. Sure, you could make up a catechism and teach it to your kids, and that'd be great. And
well, potentially, you know.
yeah, you don't have any kids, but yeah, right. Yeah.
That too.
It might be great. There is this sense of like, well, it's hard to improve on it.
Right.
They did meet, 1,300 times over the course of this,
Wow.
putting this together, right? And so you do get the sense when you're studying the catechism, like every word of this is loaded.
Yeah.
Like they chose this word and not any other word. Like it's dense. And when you're teaching it, I get to teach it to kids, which is super fun. And you get to explain like, okay, this is what this word means. And then you get to unpack it for the 8-year-olds and show like this is where it, all the weight this word is carrying. So it hasn't been improved upon. The Heidelberg is also great. It just does something a little different.
What's the difference there?
Largely, the Westminster is more doctrinal.
Okay.
It is more like here is the objective
Truth.
The Heidelberg is more personal, more subjective in a way. Like, what is it for me? So you can see that
Got
difference
it. Okay.
in the first two. The first question of each. The first question of the Westminster is, what's the chief end of man? Right. First question of the Heidelberg is, what is your only comfort in life and death? Right. Both wonderful.
Right.
But one is saying, look at God, and one is saying, look at me.
Right.
Both good. Both
Yeah.
necessary.
And is the Westminster tied to the actual
Confession?
Westminster?
Yeah.
Okay.
It was produced at the same time.
Okay. Got it. And what caused them to meet 1,300 times and put together this manifesto, as it were?
So this is during the period where Parliament is ruling England. Charles I has been beheaded. Charles II has not been reinstalled. So the Protestant Parliament defeated the Catholic king, essentially.
Okay.
And so this is 1640. They met a number of times, but 1643 to 1647, give or take, in that period, somewhere in there. And this is the Reformed, or at least the Protestant. I guess the Protestant Parliament saying, okay, we need to have. I'm sure it was in some ways a unifying measure, right? We need to have a clear understanding of what we believe. Again, the things have been theologically swirling for 100 years. Let's define things.
Yeah, and was the idea that it would that would be used in government? Or
it does have political ramifications.
Okay.
And there are differences between the American version of the Westminster and the English version of the Westminster, particularly in that. So while the Westminster Confession and thus the Catechism as well was not intended to have a political dimension, it was intended to be an ecclesiastical document.
Right.
But it did have ramifications for the political. In the British confession, the magistrate is described as having the authority to call and preside at councils. So the king could call a gathering of the pastors and scholars and could preside at it.
Got it.
Which is very interesting.
Yeah.
Calling is one thing and presiding at is another.
Yeah.
And in the American version of the Westminster, he does not have the authority to preside.
Well, because we don't have a king.
There is that too. But magistrate could also mean governor or
okay.
president. Yeah.
Yeah, and then he can preside, but he not participate?
Correct. So he can call it. So the magistrate
Yeah.
could call and say, we need to get this bit of doctrine hammered out, right? For the sake of the Commonwealth. Now you guys go figure that out. As opposed
Got it.
to under the British confession, he would call it, and then he would say, all right, so now here's what we're going to do.
All right, gents.
Yeah, all right, gents. Exactly.
Got it. Okay.
Yeah.
And this begs the question, which I've always kind of wondered: is there a perfect form of government?
Is there a perfect form of government? Ours, obviously. I mean, this is the eternal question, and it seems like it depends on who you are and where you are.
Right.
The three fundamental forms of government: the monarchy, the aristocracy, and the democracy, or the timocracy. Those are sort of the three. Aristotle, describes those as the three possibilities.
Right.
And so, but each of them have their pros and cons, and each of them can go wrong in different ways. Aristotle preferred the monarchy. He thought that was the best overall. But of course, that depends entirely on whether you have a good king, right? So our government, of course, tries to combine all three. And so you have the elements of a monarchy in the presidency, you have the elements of a aristocracy in the Senate, and then you have the elements of a democracy or a timocracy in the House of Representatives.
Yeah, got it.
So it seemed to work okay.
Not sure, but we're giving it our best shot.
We're giving it our go. That's right.
Yes. You mentioned that each word, it feels like, is loaded.
Yeah.
Do you have an example of that kind of thing?
Oh, let's see. Well, here's an example. Question 16 says, did all mankind fall in Adam's first transgression? And the kids all joke and they say yes, right? But the answer is the covenant being made with Adam, not only for himself but for his posterity. All mankind descending from him by ordinary generation sinned in him and fell with him in his first transgression. It feels like a really long, wordy answer.
For just saying yes.
For just saying yes, right? But then when you get into it, you're like, and what's this like by ordinary generation? What on earth is that doing here? And then you think about it and you realize, well, did all mankind fall in Adam's first transgression? Actually, technically, no. Christ didn't, right? And that's key.
That's what they meant by ordinary.
That's from the ordinary generation.
Got it.
It said, yes, all mankind, which descended from Adam by ordinary generation, sinned in him. But that begs this question, what is ordinary generation? Right? And I'm explaining to the 8-year-olds, so it's like, all right, yeah, human mama, human papa, right? But Christ did not have a human papa.
Right.
He just had a human mother. So was he born by ordinary generation? Oh, no, he wasn't. So did he fall in Adam's first transgression? Oh, no, he didn't. Right? And that's key. Because unless he has a human nature, he can't atone. But if he has a human nature and sin, then he can't atone either. And so I think that's an example where it seems like the Westminster Divines are just being unnecessarily cumbersome. Like, well, actually, you needed that.
Yeah.
That was key.
Right.
Yeah.
And so it seems like then that the sin would be passed through the paternal line.
That
is that correct?
is the implication.
Okay.
That is the implication.
And so,
Yeah.
Got it. Interesting.
Oh, yes.
And there's lots more.
There's lots more. Yep.
And so should ordinary people be studying this kind of thing?
I think so. I found it rich. So right now I teach catechism classes to the kids in Christchurch. I've got about 70 kids that meet once a week, and we're just memorizing it and going through. We did it all last year, and then we're doing it this year. And when I first started, I thought, oh, this is going to be a bit of a drag, or like, boy, I'm going to really have to spice things up somehow. This isn't going to
bring lots of candy.
I do. Okay, and I do actually. But it is amazing when you really get into studying it. First of all, how very succinct it really is. Stereotypically, you think about its archaic language, which it is, and it's strange, and it's probably really dry and dusty, and it really just isn't. Like, once you pierce through the these and thous, you find that it's actually a beautiful and glorious summary of the Christian faith that's really accessible. So the first 38 questions are all on God, man, sin, atonement, Christ's work. And then the next 40 some odd questions are all on the 10 Commandments, which is where we are now in my classes. And I really thought that was going to be a drag. Like, we're just going to study the 10 Commandments for a whole year, like just memorize like what is required in the first commandment. But when we got into it, it really is a fantastic and profound summary of what the law of God requires. And as I've been studying it and preparing to teach the kids, it's just been impressed upon me more and more. Like, yeah, boy, if I kept all these, I'd be perfect. Like, if I kept all of these to their fullest extent, I would be perfect. And this is really a summary of the moral law. And the law is good, and the law is given for our happiness. So let us seek to understand how God would have us live, and this is a wonderful summary of it. So yes, I think that it should be studied by everyone, and that the archaic language actually is not a hindrance. I think the archaic language is a plus. It helps with memorization.
I'm sure that's true,
Yeah.
and it's unlikely that they will do another version.
No, yeah, they've modernized it. So the Westminster
Okay.
has been put into modern English, which I've looked at. Again, I actually think that first of all, there's something to be said for let's memorize the same stuff that has been memorized for 350, 400 years. But then also, the archaic language helps you with memorization. I think it's slightly less familiar to us, and so we memorize it more easily.
Yeah, we'll kind of move on here to physics.
Oh boy, there's
is...
my wheelhouse.
Yes, your major.
Yeah.
What inspired the study of physics? Is there a specific area that you went into?
Let's see. My degree was in general physics. It was a small Baptist college, and so it didn't specialize. So I took everything. My undergraduate research was in plasma physics. So I went to Baylor and spent a summer with their astrophysics program. Yeah.
My mom's entire family went to Baylor.
Oh, really? Very good. Oh, I had a great time there. Yeah.
Yeah.
They have a really neat center for astrophysics, space physics, and engineering research, which I worked with there. Super fun. What made me go into it initially? I think two things. One, it was hard, and I liked hard things. And two, you just are probing. You're asking the fundamental questions about the physical world, and I found that exhilarating.
Yeah. I've never understood why the apple falling on Newton's head was such a big deal. Like, surely people had discovered that things generally fall before.
My goodness!
Correct?
Watch this! Amazing.
It's like we've been doing this for a while.
Yes.
Surely. What was the discovery there?
Good. Yeah. So it actually is a profound discovery, even though it's characterized as like, surely people have figured out that things fall before. So the story goes, Newton's sitting there under the apple tree. He looks up at the apple. He thinks, apple falls. Okay, check. Got that. And then he looks past the apple to the moon. He says, the moon stays around the earth. And the key is, he says, I wonder if the moon stays around the earth for the same reason that the apple falls. Right? So it's not the discovery of gravitation. It's the application of the theory of gravity to not just Earth, but the heavens. Right? And so Newton's living and writing at a time when the understanding, the medieval understanding of the Earth is where things are changeable, the heavens are where are perfect and unchangeable. And that's been tampered with by Galileo and by Tycho Brahe and Kepler, etc. But this application that things work on Earth the same way they work in the heavens, and we can describe heavenly phenomena using earthly phenomena, actually was a huge breakthrough. And then from there, he formulates his universal law of gravitation, which mathematically describes the gravitational attraction between any two objects, which is thus gives the mathematical underpinnings that explain the observations of Kepler and others.
Right. And the idea was that the moon is falling,
Correct.
but because the Earth is so big, it just keeps falling in a circle.
Around it, exactly.
Got it.
Yep.
Okay. And that was the big discovery.
That was a big discovery. Yep.
Okay. Got it. Was there anything that he has that he stated or proved that has been proven wrong
Newton,
with the advancement of technology?
That's a good question. Newton certainly was king for hundreds of years. And Newtonian physics is what was the paradigm for our understanding of physics, really, from the time he wrote in the late 17th century up until Einstein in the early 20th. Sure, Newton had wacky ideas. Everybody has wacky ideas. As far as like the bones of Newtonian physics, they're pretty much all still valid. The probing and the expanding that's taken place in the 20th century has not invalidated Newton. It's gone further and deeper.
It's built on it.
But built on it.
Yeah. It's there. And the same question, I guess, could be asked for Einstein.
Yeah. Mm-hmm.
Is there anything that he said that's been disproven, or was he
Oh
pretty much?
yeah, I mean, like anyone who thinks as deeply and writes as much and is as
Prolific.
prolific is going to have things that didn't turn out right. However, again, in the main, yeah, the Einsteinian paradox or paradigm still holds.
What's the Einsteinian paradox?
I guess I'm referring to general relativity, special relativity.
Okay.
The even nature of light to an extent. Yeah, all of those. So I guess modern physics, which he kind of gave birth to. It has not. We have not moved past. We've moved deeper.
Yeah. And can you explain the theory of relativity? Because I have a vague and tentative grasp of what's happening.
Yes. So do most people. You have special relativity and general, so those are different. Special relativity refers to things you probably have seen in science fiction, namely that. Okay, the basic insight of special relativity is that space and time are not two things, but they're one thing. So space and time are connected, and you can. We're all moving in time, right? We're moving in time forwards. But if we move in space, right, so we walk from here to there, that affects how we move in time.
You cannot move in time without moving in space.
Correct.
Got it.
Correct. Or well, no, sorry. You are constantly moving through this thing called space-time. And if you move really, really, really fast in space, then that slows the rate that you're moving in time.
Oh, interesting. Okay.
Yes. So theoretically, if you traveled near the speed of light, you would. The twin paradox, right? So you and I are twins, born on the same day. You get on a spaceship, travel near the speed of light. You come back. Let's say you're gone for 20 years, but only 10 years have passed for you.
Interesting.
So now we're different ages.
Okay.
So
we would be still technically 20, but I would have aged 10 years. Is that correct? Or
for you, time would have traveled differently.
Okay. So then when they say that like you can only go, let's say, and the Andromeda galaxy is X amount of light years away, is that factoring in the fact that when you get to the speed of light, time slows down, or is it light years as compares to us?
It's light year is a distance. It is the distance that light travels in a year.
Right.
And so light travels at roughly 300 million meters a second. And so if you consider, so it's just basically a distance. So the Andromeda galaxy is a certain number of light years away. That means it takes light a certain amount of time to get to us. And that's just describing how far away it is.
Right. But does that mean that the light, it actually would take longer for... It takes less long for the light to get to us because it's traveling at the speed of light, and therefore the time is...
Correct.
Got it. So we would have to travel at the speed of light in order for...
Which we can't do. No massive object can. So if we wanted to reach the Andromeda galaxy, we would have to travel for a very, 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 very long time.
Yeah. Why can we not travel faster than the speed of light?
So this is based upon that same assumption, which is a model of understanding the world. Whether or not it's strictly speaking true is hard to pin down. It is consistent with phenomena that we've observed, but the idea that you can't that all motion in time is also motion in space and vice versa. Mm-hmm. So if you were to travel faster than the speed of light, you would no longer be traveling forward in time, and so you would potentially then travel backwards in time, which is odd.
Yes,
it has to do ultimately with energy. Basically, you have a certain amount of energy, and as you move faster and faster and faster, you approach having zero energy, but you can't have zero energy.
Having zero energy, surely you would be you would have to have an enormous amount of energy to go that fast,
right.
Correct?
Sorry. Yeah. So having zero energy in terms of
potential
energy in one dimension. Yep.
Okay.
Yeah. Sorry.
There's a lot of confusing stuff.
A lot there. Yeah.
Is it true that this is somewhat unrelated? Heavier objects always don't necessarily fall faster than lighter ones?
So that's the what Galileo set out to demonstrate based upon Aristotle, heavier objects fall faster. He demonstrated that that is not strictly speaking true. The reason why heavier objects seem to fall faster is because of air resistance. So air resistance tends to affect more massive objects less than it affects lighter objects. So in a vacuum, all objects fall at the same rate.
Right.
So maybe you've seen is a great video of this big
the feather and
the feather and the ball. Yeah,
yes.
That's great.
Yeah, yeah.
Great.
But as far as like, I could drop a bowling ball and I could drop that TV remote.
Same.
And okay,
Yep.
there we go.
Yep.
This is also slightly off topic, but it seems that humans are at least somewhat partially trapped on our spinning ball of rock, and even if not there, like we've gotten to the moon,
Yep.
And the hope is to get to Mars. But it would be vastly difficult to get just outside of our solar system.
Correct.
Is there a theological reason why everything is so spread out, and it seems like there's a whole lot of barriers we'd have to cross?
Mm-hmm. Yeah, it's a good question. It seems that God is very big, and He likes reminding us of that, and so we see His nature reflected in the created world, and so He made the world very, very big, and it seems like He did that because He could, and in order to reflect aspects of Himself. So when we look up and we realize how far away these things are, how big the world, the cosmos that God has made, and I don't think that He put these barriers to make it impossible for us to overcome them. Clearly we have, to an extent, and plan to do so in the future. And I don't see a theological reason why we would be prohibited from exploring further reaches of our solar system or further. I think He made it really big because it reflects His glory.
Yeah. You mentioned that you studied specifically plasma.
Yeah.
What is the deal with plasma?
I spent a long time trying to figure that out.
Yes.
Basically, this is the short version. You have three states of matter. You have solids, liquids, gases, right?
Mm-hmm.
You take solids, you heat them, you get liquids, right? They melt.
Right.
You take liquids, you heat them, they evaporate, you get gases. What happens if you heat gases? Turns out, if you apply more energy, which is what heating is, you apply more energy to gases, you can cause them to ionize, which means you get the electrons that orbit the nuclei, they actually rip apart. And so instead of having nice, tidy atoms with nucleus at the center and electrons orbiting, instead you have this free-flowing soup of nuclei and electrons kind of just doing their thing. When you do this, it releases a huge amount of energy.
Isn't that what makes a nuclear warhead?
No. A nuclear weapon is usually produced by fission of the nucleus itself.
Got it. Okay, so not separating the proton.
Correct.
Got it. Okay.
Yeah. But pulling apart the electrons from the nuclei also releases energy, usually in the form of light and heat. We see that most commonly in our day-to-day lives in lightning. Lightning is electrons jumping from cloud to ground or cloud to tree or cloud to whatever. And as those electrons pass through the air, they ionize the air. So they actually smash apart the air molecules, causing them to release a huge amount of light and heat. But that light and heat is not the electricity, interestingly enough. It's the result of the electricity passing. And then the free protons, neutrons, and electrons, or the free nuclei and electrons, takes up a lot less space than atoms. And so the air creates a close to a vacuum. The air then collapses in on it, which is thunder.
That's the boom.
That's the boom.
Got it.
Yeah.
Okay.
So plasma is that soup of free nuclei and electrons releasing energy before eventually recombining when they reach a lower energy state. Yeah.
So plasma is just, hey, look, we can kind of control lightning a little bit.
Yeah, basically. Mm-hmm.
Okay.
Yeah.
So what is the practical use of studying all of that?
Two things. One, spacecraft reentry. So you've probably seen when a spacecraft re-enters Earth's atmosphere, it gets that glow around it, right? Why? Well, it's doing what electrons do. It's smashing apart air molecules. So it's creating plasma around itself as it comes back into Earth's atmosphere.
Interesting.
So in order to understand what effect that will have on the spacecraft, we want to be able to create controlled plasma on Earth, right, so that we can test and see what's going to happen. Okay, so that's one, so spacecraft reentry. The far more interesting one is nuclear fusion. So
that is far more interesting.
So you have two forms of nuclear energy: nuclear fission, nuclear fusion.
Yep.
Fission is when you take a really big atom like uranium and you split it apart. It releases a little bit of energy, but it also releases more neutrons, which then can cause other atoms to fission.
Chain reaction.
Yep. Ding, ding, ding. So super great because you can get that chain reaction.
Yeah.
Not so great because the byproducts are horribly radioactive.
Yeah, that's awkward.
So awkward. So you seal it up in big containers, you drop them in the bottom of swimming pools, and you leave them there. Perfectly safe. Fusion is the opposite. It's when you take two very small atoms and you smash them together. They also produce energy.
And that would create a new particle, correct?
Correct. Yes.
Yeah. Okay.
Yeah. So you take two hydrogens, you smash them together, make a helium. Yeah.
Got it.
Which is not radioactive. But the problem is you don't get the chain reaction.
Yes, because there's no outflow.
Exactly.
It's just
there is an outflow, but it's not like you can trigger. It's not like the fusion was going to happen anyways. The fission potentially was going to happen anyways, right?
Yeah.
The atoms are unstable, but the fusion's not going to happen anyways. So. The plus is the fuel's basically free, it's just hydrogen, and the byproducts are not radioactive, it's just helium, super great. Problem is you don't get that chain reaction. So how do you convince the atoms to fuse? You may have heard of cold fusion, which is kind of like a holy grail hope of trying to be able to do that in a way that doesn't involve hugely intense temperatures. Because the only way we have of doing it now is basically...
if we heat everything up, eventually
it all smashes together. Exactly.
Got it.
So the question is, how do we heat stuff up?
And that would be plasma.
And why plasma as opposed to something else? Because plasma is magnetic. So you can actually control it with magnetic fields, which means it doesn't have to touch anything. So you basically make a huge swirling donut of fire, and you put your hydrogen in that, and you control the swirling donut of fire by magnetism, and that's what causes the fusion.
Why is it magnetic?
It's magnetic because magnetism is just moving charges. So magnetism is just the byproduct of a moving charge. So with the plasma, you have moving electrons and protons.
Okay.
And so you have these moving charges, which means they're producing magnetic fields. So you can control them by magnetic fields.
Got it. Okay. And cold fusion, is there any idea of how that would happen? No? Okay.
That's why it's this holy grail.
Right.
Yeah.
Why is it that when you put a grape in a microwave, it creates plasma?
I have thought about that, and I don't think I have a succinct answer for you.
Okay.
It creates arcing, right?
Yeah.
And that, no, I don't know.
Sure.
I'm aware of it, and I don't know the phenomenon.
Yeah. Well, obviously, we got to put more grapes in
Clearly.
microwaves.
Just more things in microwaves generally. Yep.
Yes.
Mm-hmm.
Okay. So that's the practical application of plasma.
Correct.
Is there any possibility that could be used to transport items?
Transport plasma?
As far as a kind of...
propulsion.
Yeah, propulsion of fuel.
Yes, thank you. That's very good. Yeah. That is exactly right. Yep. It can be used for a fairly low... it's not low energy... propulsion system. It would not be applicable for getting stuff off of Earth.
Right.
But having gotten something off of Earth, it's very applicable for transporting it through space.
Because there's no air.
Exactly. And so you can just give this slow acceleration, but with no air resistance, it just will get faster and faster and faster and faster. So yes, that's the other application. Very good.
Okay. So how do you, because surely you need air molecules in order to create plasma.
Well, you need some sort of gas.
Yeah. And how does plasma, how can it accelerate something?
Right. So this is Newton's third law. Any action has an equal and opposite reaction, which is the basis behind all propulsion systems. So essentially, as you are pointing basically your plasma production device, whatever it is, in one direction, it throws particles in that direction, which pushes you the other way. So it's basically the same thing as standing on ice and throwing a baseball.
Yep.
Right, which would move you very slightly. If you could throw 1,000 baseballs a second, it would throw you a lot faster. It would move you a lot faster.
Right.
So that's the general idea. The actual mechanism I haven't studied.
Okay, got it. And is there any possibility that because of its magnetic abilities, we could use it to, for instance, maglev trains are becoming a possibility in places like Japan? Is that the kind of thing that?
I don't think that's the area of application.
Okay. Yeah.
Mm-hmm.
Black holes have always fascinated me.
Don't they for everybody? Yes.
Yes. There's a lot of people who kind of wish, maybe somewhat preposterously, that they were a door as opposed to just a hole.
Fire stuff into the black hole.
And it'll shoot out somewhere else.
That's
Is there any basis for that, or is that just kind of a pipe dream?
I don't think it's as much a pipe dream as it is a imaginative grappling with the fact that we have no stinking idea what's going on.
Okay.
And this delightful impossibility of ever knowing, right? So
which is kind of fun.
Which is kind of fun, right? So I don't think that it's realistically like people actually think it in any sort of scientific way that it is a hole to another dimension. But golly, what is it, right? And as far as we understand, matter in a black hole is working differently than we see matter working anywhere else, to the point of breaking all laws of physics.
That's time and space are ripped apart.
Time,
correct?
Space, matter, it's all a mess. Yeah. So heck, why not? Yeah.
Right.
Maybe it does take you somewhere else. It changes all. Yeah. So I think thinking of it as a portal is just sort of a kind of throwing your hands up in the air and saying like, well, none of the other laws of physics work there, why not?
Yeah, exactly. Yeah. Okay. It'd be nice if we had a black hole somewhat near us that we could experiment on.
Well,
at least, clarification, not one large enough that it would eat us.
Yes, that would be good.
But something small enough that...
Well, but again, the other delightful thing about a black hole is it possible to experiment on? No, it sucks in everything. You can't get information out. It's unobservable.
Right. Yeah.
And so, like, you can't get in without... If you get in far enough to see anything interesting, you can't get out. Yeah.
But there is also a theory that, like, all of the things it collects is still in there in the singularity, right? The singularity itself is also confusing.
For sure. Super weird.
Because it condenses to an infinitely small... Am I understanding that right?
Yep, you are correct.
How do we know that?
We don't. So all things involving black hole are conjecture. But the question is it conjecture that is reasonable, conjecture that is consistent with other things we observe, or not? So this goes back to Newton. Newton's universal law of gravitation says that any two objects exert a gravitational pull on each other. And that force is increased by their mass. If the object is more massive, then it exerts a stronger pull. And if the distance between it gets smaller, it exerts a stronger pull. Okay, so two objects getting closer and closer together exert a stronger and stronger pull on one another. So if you were to get further away from Earth, Earth's gravity would affect you less. Okay, as you get closer and closer and closer to something, though, it exerts a stronger and stronger force. Now imagine that we're not talking about like you and Earth, but imagine we're talking about a huge amount of just dust particles, let's say. As they all get closer and closer to each other, they're all exerting more and more force on each other, right? And eventually they get to the point where they're jostling each other, right? Bumping up against each other and whatnot. But that force still is crushing them down, right? Eventually, this is our best understanding of how stars work, eventually they get to the point where they are tight enough that they start fusing. And so those
not because of heat.
It essentially, heat kind of breaks down at that point, but it would, if you were there, you would think it was very hot. But yes, huge amounts of energy in these tiny particles. So yes, it would be very hot. And they are all jostling each other, starting to fuse, and then releasing energy. So they continue to do that until you've used up all the hydrogen.
Okay.
And now you need more energy, but that force pushing outwards was what was keeping it all from collapsing. As that fusion goes away, well, now what's preventing it from crushing inwards again? Nothing. So it crushes inwards. And so the gravitational just keeps on squeezing. But eventually it squeezes hard enough that it starts fusing the helium, right?
Right.
Okay, and that releases more energy, and then it explodes out again, right? But then eventually you use up all the helium. And so then it crushes. And so the theory with black holes is if you have a large enough amount of matter, eventually, if you don't have a large enough amount of matter, eventually it just goes to lead, and you're like, well, we're done.
Here we are with a lot of lead.
Here we are with a lot of lead, right? And that's when it's called a brown dwarf or something like that.
Okay.
The idea is if you have enough material, eventually the gravitational force just crushes until it rips everything apart and just crushes down ultimately to an infinitesimal point.
And the reason that things spaghettify as they enter a black hole is because they're having to be pushed into an infinitely small point. Is that correct?
Not exactly. It's because, let's say that you were flying towards a black hole feet first.
Okay.
The gravitational force increases as distance decreases.
Mm-hmm.
So at some point, your feet are closer to the black hole than your head.
Right.
So your feet are being pulled more than your head.
Right. And because it's because the effect is so magnificent and huge.
Yep. Eventually, that difference rips you apart.
Got it. Yep. Okay. And is there any concern that when we produce fission bombs, we will create a small black hole? No.
The definition of a black hole involves a huge amount of mass. So I think, if I remember this correctly, you need, for a black hole to be possible, according to our models of the universe, you need 2.3 solar masses. So you need something 2.3 times the size of our sun.
Okay. So. Got it. So it's unlikely we could create one.
Unlikely.
Yes. Yeah. Okay. Got it. Have you taken any time and looked at the quantum realm?
If you're referring to Ant-Man, I have one rule in my physics classes, which is no talking about Ant-Man.
Don't watch it. Don't look at it.
No, it's a very funny movie that I don't want to talk about. I have taken courses in quantum mechanics. I'm familiar with the broad outlines of quantum theory. The quantum realm is, I think, a hilarious misnomer.
I am not really concerned with that. My question is more like quantum computers and things such as that.
Mm-hmm.
They're acting as if this is a huge breakthrough.
Yeah.
And I saw a video where they were showing the Google has this quantum computer, and they showed the chip, and it looks like a regular CPU.
Yep.
But then it's got this huge cooling mechanism.
Yep.
What is the big breakthrough that makes quantum mechanics so exciting?
Okay. Okay, huge question there. I will give a caveat, and that is I am not up on any current developments in quantum computing. So I'm aware of the basic idea, but I've got nothing current. So quantum mechanics essentially says that when really, really small stuff behaves weirdly. So that's the short version. To the point where the difference between a particle and a wave is non-existent. So all things that we think of as particles, like protons, neutrons, electrons, etc., we could also think of as waves, which is deeply strange.
Interesting.
Yes. And we see particle and wave-like behavior in all matter. Okay. Quantum mechanics seeks to take seriously and to mathematically describe the wave-like properties of subatomic particles. So essentially, how do we understand how matter behaves when it's really, really small? This has produced deeply strange and baffling realities, related to which, and I think maybe we'll get to some things you wanted to talk about later, but the observation changes the system. Okay, Schrodinger's cat.
Yeah.
Okay. So Schrodinger's cat is an absurd illustration. Obviously you opening the box doesn't make the cat alive or dead, right? That's preposterous. And yet that actually is what we seem to understand being true on the quantum level. So you observing a system actually does change it. So until you observed, the electron wasn't there. The electron wasn't anywhere until you observed it. Okay.
Now I'm fully lost.
Good. That's fair. So maybe another way of putting it is, we think of, if you were taught in high school chemistry, that electrons orbit protons.
Right.
Electrons, right? And you've got these different rings and these different orbitals, right? But then you were probably also taught, or at least alluded to in high school chemistry, that it's not really a planetary ring. It's more like a cloud that the electron can inhabit. It's worse than that. It turns out that the electron isn't necessarily anywhere. It's not necessarily a particle.
Right.
It's a wave vibrating and existing in potentia around the nucleus until you observe. And when you observe it, it is in a particular place.
Okay, because we can only observe particles as opposed to waves. Correct.
Basically.
And so, but that doesn't that make it like it's there, but it's there as a particle and a wave. We can just only observe one part
It's
of
particle-like properties. It's the trick is that particles and waves, particle properties and wave properties are mutually exclusive, right? It has to be a particle or a wave. Like the way we understand particles is that they're, like marbles. And the way we understand waves is that they're mediated by some, like they travel in some medium. They are not necessarily distinctly anywhere. Like those are mutually exclusive, and yet we see both properties when we perform experiments.
And is the reason that it becomes visible once we observe it because of the method we're using to observe it? So
Yes.
there's electron microscopes and things like that?
Electron microscopes, possibly. Yeah.
Okay.
And what's really interesting about this is it seems to indicate that the human mind is fundamentally different from the physical world.
Explain.
What is observation? Right.
We take in data.
Right.
Our brain processes it.
Correct.
Understands.
Correct. Right.
Hopefully.
If you were to observe it with another instrument, right, that's not the same thing as observing it with your mind,
Mhm.
right? And so it seems to indicate, if it is true that observing a system changes a system, we observe via our minds, right? We observe via the non-physical aspect of us, right? And yet that is mediated by physical senses, etc. But it is actually the immaterial component of us that is causing this change in the physical world, which is deeply odd.
Wait. So the fact that our mind
Yes.
is observing it actually changes
Yes.
the particles themselves?
Yes.
And so they're somehow linked.
Yes.
Correct. Is that what quantum
Yes.
linking is? Or quantum...
Quantum entanglement is slightly
That one.
different,
Okay.
but this is one of the implications of the Copenhagen interpretation of quantum mechanics, which is very strange.
I see how physicists go mad.
Okay, yes,
Yeah.
you do. Mm-hmm.
This is hilarious.
Uh-huh.
So if we could observe the information with just our eyes, and
Yeah.
they could compute it,
Mm-hmm.
as opposed to it going through our brains,
Mm-hmm.
then it would continue being
Presumably,
a wave as opposed to a particle.
or the wave function would not collapse, is how we usually talk about it.
Okay. And is there the reason that we can only, when we observe it, it becomes something different? It's part of that, like our brain can only process a particle, and so at some level, like it sees the wave and it has to pinpoint, and no, it has to be a particle, or this doesn't make sense.
It's
or...
obviously deeply strange.
Yes.
But I think I misspoke earlier. It's not that we can only observe particles. We can observe waves, right? You can see waves in the ocean. You can see waves on a string,
Right.
It's a question of what does location have any meaning when you're not observing it, right? So the classical interpretation, or again the Copenhagen interpretation, is that when you observe it, the wave function of potential locations, it could be anywhere, collapses, and it actually is now somewhere, but it wasn't anywhere before you observed.
And we have no idea why us observing it
Correct.
creates that.
Correct.
Okay. And if we were to discover that, is there like some sort of are there practical applications to that?
Yes. First of all, going back, the delightful thing about quantum mechanics is that we seem to have, in a moment, physics became the humblest of the disciplines, because it realized that there are certain things that are just unknowable. So you may have heard of the Heisenberg uncertainty principle. If you haven't, that's okay. But the Heisenberg, German physicist in the 1930s and 40s and 50s, he basically mathematically demonstrated that there are certain things about a particle that cannot be known. They cannot be known with certainty. And the more certainty we have in one area, the less certainty we have in another. So this epistemological limitation that is not based upon our instrumentation, but is based upon the system itself. So it can't be known.
Right. So like the more we observe its location in space, the less we observe its location in time,
Basically,
or something
yes.
like that.
Yeah.
Okay.
Which is really profoundly strange.
Yes. And so what was the break like how does that affect quantum computing?
Yes, yeah. So the idea with quantum computing is that the particle or the wave function, so to speak, exists in a whole bunch of states at once, right? And it's not clearly defined to be one way. It's got a whole bunch of states that it is existing in at once, and a quantum computer can use that sort of simultaneous existence of the potential states of all these different particles, and it can use them to perform essentially lots of calculations at once. So if you think of it as normally you have one circuit, right? Open, close, right? A quantum computer can have a bunch of them open at once.
The idea is to harness the cloud, and because we don't know where its location is, it can be open and closed in multiple different spots at the same time.
That's the very, very, very rough outline. Yep.
Yes.
Which is about all I know either. So,
yes.
Yeah.
Got it.
Yeah.
I need to have a quantum physicist on here.
Yes, you do.
I can just be more and more confused throughout the conversation.
Yep.
There's also something they refer to as dark energy.
Yeah.
Which is negative energy, or
is it negative? My understanding of dark energy and dark matter is matter and energy that we know has to exist because we observe its effects, but that we don't have any idea what it is.
So similar to a black hole, in a sense.
In a sense, this is one of my favorite physics just factoids that we think that approximately 4% of the universe is made of atoms.
Oh.
And the rest of the universe is made of something else.
We don't know.
We don't know. We have observed its effects. Basically, when you look at the grand sweep of the cosmos and the positions of stars and galaxies and stuff, there seems to be more going on than should be going on if it was just conventional matter.
Meaning,
I guess maybe kind of like a black hole, if you were to see a star orbiting something and you saw nothing there, right? Stars going around, nothing's there. There's got to be something there.
Right.
And then
that's a black hole.
That's a black hole. Okay. Or it could be, right?
Right.
Imagine that kind of writ larger. So the whole motion of everything, or large sections of galaxies, their motion does not make sense if our understanding of matter is complete. So there's not enough matter to explain the motion of the cosmos.
So it's like all of these galaxies are spinning around, and they're gravitationally linked, kind of to each other.
Or this one's not moving as fast as it should be, right? Based upon what's near it. Or that one's moving too fast based upon what's near it. So what gives?
And it seems like there's some kind of vacuum. Like the dark energy is literally like.
Is it pulling or pushing? Yes.
The absence of.
Yeah. So a dark energy is a scary name or a science fiction-y name. It basically just means energy we don't know what it is.
We can't observe it.
We have not observed it, but we know it's got to be there. Same with dark matter. Dark matter is matter that we know has to be there because it's the only thing that will explain the motion of the cosmos, but we don't know what it is. So there's different theories. Right. My favorite one is that it's a weakly interacting massive particle, or a WIMP, which is just delightful. So lots and lots of WIMPs.
Yes, lots and lots of WIMPs. And so if we were to discover, or at least be able to observe, what would the implications of that be?
I mean, if, as you put it, we discovered what dark energy or dark matter was, it would probably involve a fundamental reworking of our understanding of astrophysics.
Okay.
Just like, the model we had for describing the world is, we know it's insufficient, clearly.
Right.
But we just don't know how to fix it. And so this would be, it's possible that it would be, that it would not have any practical implications, and it's possible that it would be another Copernican revolution.
Is it possible that we discover it?
Yeah. Mm-hmm. There's really interesting stuff going on with neutrinos right now, which are a candidate for dark matter because they don't interact with hardly anything electrically. And so there's neutrino observatories that are doing really interesting work. So it was recently discovered, I think in 2015, that neutrinos actually do have mass, which means that they're a potential candidate. So yes,
a neutrino is
a very small particle that doesn't interact, that is neutrally charged, so it doesn't interact with anything electrically. And thus there's, millions of them passing through your body every second.
And we don't know how to harness it or observe it or anything like that.
Because with no electrical component, it avoids all magnetic, all electrical interactions. So,
which is how we observe things.
Which is how we observe things, which is how we attract things, which is how we control things.
So we would have to rework our observation methods in order to see it in the first place.
And this is maybe a side note, my personal theory is that my gut says that we are, in the next 100 years, we will have a major reworking of our understanding of charge. That's my gut.
Of the electrical charge.
Of the electrical charge.
Got it. Yeah. My dad has a theory, which I think he has theological reasons for, that the universe, everything is made up of sound.
Yep.
I think he bases that off of God spoke the world into existence, and so rather than forming, it became the form. Is there scientific basis for that?
This goes back to what we were saying about particles and waves, right?
Right.
What is a wave? Right. Well, waves are how we make sound. Right. The reason why there's sound happening right now is because my vocal cords are vibrating, right? Waves.
Yeah.
How do we make sounds on instruments, right? We have waves on strings or waves in the air. So if you take quantum mechanics a particular direction, you interpret all particles are also waves. Thus, they are all vibrations. They're all notes, right? And so this image of every atom being, a little sub movement of a symphony, right? All the little particles of it vibrating in different ways is actually, I think, an entirely legitimate way of looking at the world.
And maybe one day we'll be able to hear it.
Yeah, exactly.
Which would be kind of fun.
Be wild.
There's a contradiction that many top scientists run into, where it's not a contradiction, but they see it as such. Where the more they understand and learn about the explainable parts of the universe, the more the less they see they need to believe in God, because they see God as kind of like a dump of I don't know. It's God. And so the question is, where are they going wrong with that?
What you're describing there is kind of the classic aftermath of Newton. Newton describes the world in these fixed mathematical laws, and at the same time, the Enlightenment thinkers, Voltaire and the others, look at this and say, "Oh, okay, so I don't need to think of God as permeating all of existence, mediating everything. We have these mathematical laws, right? They do what we called God, now I understand, are just these mathematical laws." Okay, so yes, you have this deterministic stance where physicists in the 19th century particularly looked at the world and said, hey, give me the initial conditions, and this is basically just one big billiards ball collision, right? Give me the initial conditions of the first couple of billiard balls, and everything is determined, right? No God, no need. It's just one big, right? Interestingly, I think with the advent of modern physics in the 20th century, physics at least goes the opposite direction. I think physics is, and I think this is backed up. I wish that I'd remember where I saw this, but physicists are the most likely, in the scientific fields, physicists are the most likely to believe in the supernatural.
Oh, interesting.
Yes.
Well, it kind of makes sense.
It does.
Because as we've been exploring this topic, I realize how little I know.
Exactly. And the more you look, the closer you look, the stranger you realize things are. And the deeper the mysteries, and the more evident it is that our models are woefully inadequate. And sure, we've made really big bombs, and we've allowed technological marvels, yes, but as far as understanding on the deepest level, we've tried, and we've come up with epistemological limitations and things that contradict our senses, and I think that it inevitably drives you towards some sort of explanation outside the physical world.
Or madness.
Fair enough. Yeah.
You mentioned epistemological limitations.
Yep.
What do you mean by that?
Heisenberg's uncertainty principle. Right?
Okay.
There's things
like
that it's not just, our limitation is not just because our microscopes aren't good enough. We actually can't know.
Right.
The existence or
Got it.
the location and momentum of these particles. Like, it can't be known, which is weird.
That yet.
No. Like, period.
Oh, okay.
Cannot be known.
Like
there
will
is
never be a
there
moment.
is correct.
Okay.
That's the implications of the theory at this point, right? So
Right.
it's not demonstrated by physical observations like, man, we've tried and it's really hard. It's like, no, we begin with certain mathematical assumptions, we reason to conclusions, and the conclusion is can't know. Uncertainty must exist.
So is there a possibility that at some point the mathematical assumptions change?
Sure. Yeah, absolutely. Yeah. But this
With what we
mathematical
have
assumption,
right now.
it has not been challenged.
Right.
Yeah.
Yeah. It's a pretty good assumption. And at the end of it, we don't know.
Correct.
Got it. Are there any things in physics that you don't think we'll ever figure out?
Oh. In some ways, I think yes. Well, yes and no. I think we'll be continuing to study the physical world to eternity, right? I think that
Right,
physics will
yeah.
still happen in the new heavens and the new earth, and I think there'll be constant exploration. And I think that we will continue to bring theories before the throne of God, and He'll go, "Wow, that was really good,"
Or horribly wrong.
it was really good, but not right yet.
Yep.
Right. And
Keep trying.
I think there'll be deeper and deeper layers and more and more and more to explore. So in the sense, like, I don't think it'll ever be solved. Just like we will never write the final poem. It's not like we'll
Right.
ever write a poem that's like, all right,
Or
now
the
we're
perfect poem.
now we're done. Right. I think physics is the same.
Yeah.
So I think it will always go on and on and on and on and on. To the glory
That's
of
the
God.
hope.
That's the
That's the hope,
Yep.
at least.
Yep. Mhm.
For a Christian, though, who's looking to start in physics or any mathematical field, it is, for a large part, dominated by non-believers
Yeah.
who are pretty aggressively non-believers.
Mhm.
What would you give as a piece of advice or encouragement to them, to the person in that situation?
I think this is the best time to go into physics as a Christian. It's dominated by atheists, as most scholarly fields are. But again, it's dominated by atheists who have looked on, to some extent or another, the fundamental inadequacies of human reason, and they are thus, I think, desperate for explanations outside of the material world. And the
Right.
Christian has answers.
Yeah.
Right. And so I think that we will see, as the years go on, it be actually the Christian physicists, the ones who are grounded in God made the world, and I think there is a world to observe, and I think that it has order to it, and I can say why there's order to it. It'll be the people with those convictions who will actually make interesting breakthroughs,
Right.
as opposed to the others who will devolve into madness.
Yeah. And there's never going to be, because God is who He is, there's never going to be a point where we understand all of it so much that they would be almost reasonable in explaining away God.
No.
Yeah.
And all trends in the last 200 years have been in the opposite direction.
The more you learn, the less you know.
Oh no! Right?
Yeah.
Exactly.
Yeah.
Yeah.
As we kind of wrap up here, I always like to ask, what's your best piece of advice you would give to anyone watching?
Read your Bible.
Yeah.
Read your Bible.
Pretty darn good one.
Yep.
Yep.
There it is.
Where can people find you and your work and all of the things online?
Moscow.
Yes.
If you look carefully enough. I blog infrequently at Josh Edgren at WordPress or something. JoshEdgren.com. I don't remember. I don't blog frequently. So
There you go.
best of luck to find me.
Yes. There you go. I'll put links in the description.
Okay.
Thank you so much for coming on
As
the show.
a
It's
pleasure.
been wonderful.
Yep. Good. Thank you, sir.
Appreciate it.
Yep.
See you guys.